Hello students, now we will be discussing about formation of Zwitter ions and classification of alpha amino acids. So let's start with the first, that is formation of Zwitter ion. We have an amino acid that is nothing but a compound in which there are two major groups. The first one is C double bond OOH, that is an acidic group. And if it is an acidic group, you would donate H+. Similarly, there is a group that is NH2. Now, acidic group always donates H+ ions, whereas basic always accepts H+ ions. And if this happens, then carboxylic group would give me one H+ ion, which would be accepted by NH2. What would happen after this? Now, we would get a compound that is nothing but CHNH3RCOO. But now, COO would give rise to a carboxylate ion, whereas NH3 would now be positive. And thus, we can rightly say that all the amino acids would exist as like salt or behave like salt because it has presence of both the groups, that is acidic as well as basic, into the same molecule. Also, we can say that whenever such molecules originate, that is in the same molecule you have both the charges, these ions would be called as Zwitter ions or bipolar ions. Now, let's move towards the next part, that is classification of amino acids. They are classified into three categories: acidic, basic, and neutral. Let's take an example. Suppose we have this amino acid, but now instead of R, we are taking a group that is nothing but CH3COOH. Now, students, just recollect or just see this molecule and tell me how many acidic groups are present into a molecule of aspartic acid. There are two. So we have two acidic groups. You have one basic group, and now therefore we can say this molecule of aspartic acid would be acidic in nature. Why? Because the number of acidic group increases or is exceeding the number of basic groups. Similarly, few more example for this is glutamic acid. Further, let's see, we have one more amino acid, but now again instead of R, we put CH2 4 times NH2. That is nothing but we are talking about a molecule lysine. What would happen? Again, how many basic groups? Two basic groups. How many acidic groups? One acidic group. So again, this amino acid has to be basic. Why? Because the number of basic groups exceeds the number of acidic group. Example for this are arginine and histidine. Next, let's talk about the next, that is neutral amino acids. Here, in this case, suppose if R was removed and H was placed, that means we are talking about an amino acid that is glycine. How many acidic groups? One acidic group. How many basic groups? One basic group. That means in this molecule right now, number of amino groups and acidic groups are same, and thus the acidic or thus the amino acid should be neutral in nature. Some few examples for this are alanine, valine, leucine, and isoleucine. Let's now go further and discuss the next categorization. Amino acids can also be classified as essential and non-essential. What are essential? Then these are the amino acids which are required by the body. It cannot be produced inside the human body. Whereas what are non-essentials, then these are the amino acids which can be produced inside the human body itself. Examples for this is histidine, that is essential, is histidine, arginine, isoleucine, Non-essential, you have examples like glutamine, glutamate, or cysteine. So, this was all about this module, students. Meet you in the next module. Till then, thank you.